Good morning. Good morning, everyone.
Good morning.
So
Good morning.
today we're going to talk about combination. And before we start, I'd like to review our last lesson. We talked about permutations. Who can tell me what permutations are? Jacob?
Yes, sir.
Yeah, tell us what permutations are.
I'm sorry, I forgot.
Mrs. Langard to help.
Yes, permutation is the arrangement of items in which order matters.
Okay, good. So permutations are ways where a set of objects are arranged in a specific order. What else did we learn on the last class? Teresia?
We learned about combinations and factorials.
So we didn't learn about combination, but we learned about factorials. So what are factorials? Can you expound?
Yes, a factorial is a mathematical operation that you write like in maybe n factorial to represent the multiplication of all numbers between 1 and n.
Yeah, so it's, basically a factorial is a multiplication between successive numbers between 1 and n. So today we'll talk about combinations and our learning objectives for this lesson. By the end of this session, we should be able to define the term combination, contrast the relationship between permutations and combinations. Then thereafter, you will apply the concept of combinations to solve certain problems. So combinations, who can read us for us the definition of combinations? Jacob, are you there?
Yes, I'm here.
Read for us.
Okay, these are different ways we can select a group of objects from a set without considering the order.
Yeah, exactly. So combinations are ways we can select a group of objects from a set without considering the order. We saw from permutations, we consider the order. For instance, we have a set of 5 balls. So in permutations, the order is considered, but in combinations, the order is not considered. Let's say in this slide, we can see that we have certain permutations. We have 5 balls and we have selected 2 balls each from that 5 balls. So you can have around 20 permutations. But if we want to find the combinations of different ways of selecting 2 balls, then the order, we will not consider the order. What I mean is, if you have this red ball here and this black ball here, so if you have this order and this order, they are both the same. So they'll become the same combination, but they're different permutations. So who can tell or identify some other balls which have the same order? Anyone? I can check. Stella? Stella, are you there? We can have Teresia. You can identify another set which are the same combination.
Let me try.
Yes.
We
Try.
yellow and green and yellow.
Green and yellow.
Yellow. Yes.
Green and yellow, and you have green and yellow. So these are the same combination. So if you remove all repetitions or the same combination, we have this. We have a black ball and a red ball, and the rest. So this can be expressed as n combination R, where n is the total number of options or elements available. R is the number of options or elements chosen or selected at a time. So, what can you say is the difference between permutation and combination from that explanation? Jacob?
Yes, sir.
Tell us the difference between permutations and combination.
Permutations, you have said the selected objects, the order does not matter,
Yes.
where in combination, order matters a lot.
So you have interchanged. In permutations, the order matters, while in combination, the order does not matter. So we have a relationship between permutation and combination. So from who can take us through that, this slide? Can choose Mrs. Langat. Mrs. Langat, take us through.
Okay. Combination formula. From the permutation formula, we can deduce the combination formula. From the above example, we saw that 5 permutations 2 is equal to 20, and 5 combination 2 is equals to 10. We can already see that combination are obtained from permutation, and if we arrange the combination in 2 ways, we get the number of permutations, which is 2 factorial. For that matter, these 2 factorials in the notation n permutation R is equals to, or n combination R represents R. Therefore, combinations can be arranged R ways to get permutation represented as R factorials. That is n combination R multiplied by R factorials is equal to n permutation R.
Have we understood what you had just read, or do you need some extra explanation? So basically what she had said, if you have these permutations, from these permutations, 5 permutation 2, we have 20 objects, but 5 combination 2, we have 10 different ways of selecting these objects. So combinations are basically derived from permutations. So, and it has a relationship. So this is the relationship: n combination R times R factorial is equals to n permutation R. And earlier on our last class, we talked about the formula for n permutation R. So these you can derive or get the formula for combinations, how to find the combination. So this is the mathematical relationship of combination and permutations. For example, if you have 7 combination 4, so you can tell us what is n and what is R in this situation. Yes, Jacob.
Yes, n is 7.
Thank you.
R is 4.
R is 4. So in this formula, here, we input our values. So n is 7 and R is 4. So we input or we tabulate. Is it tabulate or compute? We compute our values and put them here. Then we can have 7 factorial all over 4 factorial into the bracket 7 minus 4 factorial. So this is our solution, 35. So 7 combination 4 is 35. Now I want you to engage in a problem. I want you to try to find different So this is the problem. How many different combinations can be formed for passcode of length 4, 6, 8, and 12, assuming they consist of numbers only? Who can try? Or maybe just think for 2 minutes, then you can give me the solution. So first, who can try? Who can try? Jacob?
I'm still working on it.
Still working. Teresia? So with me, I want to give you the solution. So we are trying to make different combinations here, combinations for passcodes of lengths 4, 6, 8, and 12, assuming they consist numbers only. So our n in this case, n is equals to, so how many numbers do you have?
4.
Total numbers that you have in the number line. We have from 0 to 9. So how many numbers are those?
There are 10.
There are 10. So n is 10. What about r? So in our first case, we are said we are forming passcodes with the length 4. So in our first case, we can have the length 4. The second one, you can have 6. The next, you can have 8 and 12. So using the above formula, you can get the different combinations of these passcodes that you can form. So lastly, we look at a summary, and I want you to tell me what you have learned through this lesson. So who can tell me the definition of a combination?
Yes. So combination.
Yes.
It's the process whereby number of possible we have possible arrangements in a collection of items where the order of the selections does not matter.
Yeah, so combinations are actually number of ways of selecting items from a set without considering the order. Who can tell me the relationship between permutation and combination, but the mathematical relationship? Jacob? Are you there? Stella? She's not around. Daisy? Hey guys, are you in? Or am I?
Yes, we are
alone?
in.
Give me the relationship between permutations and combinations.
We can form permutations from combination.
So what is the mathematical relationship between permutations and combinations? So we have said the mathematical relationship between combinations and permutations here, n combination r multiplied by r factorial is n permutations r. So lastly, I'll give you an assignment. So this is the assignment. Please note, it was an example that I already solved, but I want you to give me the solutions. Thank you. This is our end of the lesson.
Thank you.